everyone. Craig Tavares. I'm Director of Product Innovation and Technology at Cogeco Peer 1. So my role at Cogeco Peer 1 is to really look at emerging technologies. We look at the long-term technology strategy and roadmaps, figure out, again, what we want to do next, from a product perspective.
My name is Andre Boyson, and I'm a Chief Identity Officer at Security in Toronto. We're trying to solve the problem that we all have on the internet, which is being able to manage our online life and, more importantly, manage our online identity.
Hi, my name is Brian Turpin. I'm the VP IT of Greenwin Inc., property management company. I'm just trying to do things better with the technologies that we have. I feel like I'm in an industry that's even farther behind in the banks.
At Cogeco Peer 1, we look at it through two lenses. One, again, how we improve the operational efficiency in our business and deliver better service to our customers. And then through another lens is really how do we create the on-ramps to new technologies. So one use case that we're testing right now in AI is around improving service by implementing automation, pulling deeper analytics out of our infrastructure to increase uptime. And that use case was defined by a big investment in next-gen technology. So in our network today, we've invested a lot of money buying new routers and switches that allow for API access. It allows for use of telemetry. The API allows for automation. So now I'm removing manual workflows in my business to deliver a service or turn up a service or fix something through the API. The telemetry piece is really interesting, and again, the telemetry wasn't available in legacy technology. So legacy routers and switches that I had in my network provided very limited data to me. So if I was trying to understand the fault that occurred or try to get ahead of that fault by being proactive to fix it before it happened, the technology itself only produced a certain number of metrics that allowed me to, in some cases, be more on the reactive side than the proactive side. Telemetry is a new way of talking to my technology, new way of talking to my routers and switches, so that I'm pulling very pertinent data out of it. And now with that data, I can look at different sort of trends to say, hey, if I saw these health issues cropping up over a period of time, assimilate that data to say it leads to happen, or it would mean that something would happen in the future. Let's fix it before it happens. And then on the back end, where automation and AI is important now. So if I could predict and look at these events and predict when something might happen, the automation can now put into measure like a result where, number one, does someone get flagged? An alarm goes up and says, hey, you need to do certain kind of maintenance to this device. And it becomes what we call a closed loop automation. So the AI component of that is doing predictive analysis. AI is filling in missing pieces of information by looking at historical data and assimilating the data. And if you guys have run SIEMs or logs in your environment today, the amount of logging that comes out of any technology environment, any IT environment is massive. It's humans that look at these logs, and it's humans that have to kind of assimilate data, and nobody can do that, right? You could have armies and tons of people that could look at the logs day in, day out. It really is, again, ingesting that data and being able to make sense of it. So again, what machine learning and AI does, it takes that telemetry data, it takes all that logging data, it assimilates for you, and then it will certainly tell you, again, how to be more intelligent about managing issues before they occur.
So right now we're doing a pilot project. Our standard in our industry is you see a bunch of pictures of our units, and then you come on site, and then you actually attend the unit. We thought it would be fun. Virtual reality's now becoming a part. It's in the media. You can now run it on your iPhone. You can build cardboard boxes like this, or you can buy the standard viewers. And we thought we'd create virtual tours of our unit. So now, either via the website, or if you come up with our marketing and leasing team, we're actually branding this via Greenwin now. You can build cardboard cutouts, attach your phone, download the app, and actually do a walkthrough of our units. This is preluding to a bigger project that I have in mind of extending this virtual technology and augmented reality into building our actual buildings and replacing the clipboards. I've done some trials with the HoloLens and to see, it's not quite there yet, but that technology is coming along with 3D printers and drones. And we do a lot of serious stuff and we're pushing out technologies, and I'll walk through the office, they're like, here comes Brian, what's he gonna do now? So we wanted to also do something fun, which is why we're looking at this. And it was fun because the first time we pitched this, all the executives were looking around and then we have pictures of it, and it's just funny to see everyone trying to walk or pretend they're trying to touch a unit. We've also found we have, I think, 15 to 20% of our student housing are international students. So to get them a better feel of what they're looking at, we're providing this technology. Another nice piece is I just randomly found this company also. We've been trying to figure out who to work with. I was approached by 2 porn companies, but the optics of working with them might not have flied. But we found a startup out of Winnipeg. So it's nice that they're also a Canadian company called Grid. I met them at a tech TO, and I always say as executives, we've got to be out in the industry to see what's happening. We've had great conversations with them. I brought them into the actual industry, and it's just been fun. So we're extending that. I can actually show a demo of the virtual tours if you want to see it this weekend. And it's one of those things that no one knows what I actually do during the day. And in IT, our challenge is to portray that out to the business. What is digital transformation? Well, I'm tearing down a filing room because that whole process has gone digital. So this is just another thing where we can show what we're doing behind the scenes and actually put it in the hands and have that visual impact with our user community. Our idea is now I don't need to build a showroom. I can just have a room, and we're teaming up and having conversations with companies like IKEA because they already have their app where you can pick your IKEA chair you want, your couch. We can paint the wall and we can show you what your unit's going to look, and we can do measurements. And just a quick note, the AGO is just about to release an art session using augmented reality, and that's the big show that's about to start running also.
Yeah, so I guess one of the things like I talked about is that making sure we get the privacy model right when we're serving consumers is important. I want to, if we get time, I'd like to investigate this self-sovereign identity topic for a few minutes. But if we're going to build these networks, we've got to make sure that we can protect the consumer's interests. And so one of the challenges we were wrestling with is that in Canada, many of you probably use our service already. If you used your bank account to get to the government, that's our service. And this triple blind model that I just talked about was really an important element of making that service successful. If we told you that this is what actually what the government originally asked for, is we want the bank to produce an anonymous number, and our job was to give that anonymous number over to the government for whatever service you happen to want. And what that meant is they're going to take a single identifier and thread it through all of their programs, which is effectively creating a surveillance network. And so we created this triple blind privacy to solve that problem. In the US, we ran a similar network for the US government. It was called Connect.gov. The challenge was the US government had a different requirement. The government of Canada was in a position where they could do their own identity proofing. They could satisfy themselves Andre was Andre, so they could do their own identity proofing. The US government, because the country's so much larger and they were just in a different state with technology, they said, I love that you do the authentication up there, but if you want to do this for us, you've got to do identity and authentication. You've got to let the person get in, and you've got to prove who it is on the first visit. And so when you have a broker in this model, the problem was the middle gets to see a lot. And so what happened is the UK actually set up a very similar model. It's called the UK Verify. It was just a way for citizens to get access to government services. And so when you have identity and authentication go through the middle, through a hub, the middle gets to see a lot, which is a surveillance network. And so there was a privacy researcher out of Europe who wrote on mending two nation scale identity schemes. And what he said is his essential criticism was this, is if you had an honest but curious broker, they could peek. And what he was really saying is if the NSA wanted to, they could scoop up all the data. And so we really wrestled with how to solve this problem. And so one of the things that blockchain did for us, and this is, we wrestled with this a long time because it's a new technology, and the challenge we've got is, okay, our customers are big customers, it's government, banks, and telcos, and we're going to take this thing called blockchain, and we're going to use this to solve their problem. And it's an open source project, which has never been deployed at scale anywhere. Why would we take this stuff? Is kind of the question they were asking us. And so to get over there, the first thing was we had to clearly articulate the benefits. By using blockchain, we could actually do this triple blind privacy thing. That was our primary motivator for using it. But then the challenge is us being a company, 120 big, is how to get the bank comfortable that if there was a problem in the source code tree, and we figured we're clever, we figured out how to get a fix. How do we get the open source community to take our version of the fix for the consensus algorithm into the blockchain? So we solved that problem by finding a larger partner, IBM in this case, to help us give our customers comfort that IBM would be there if we had to take the source code tree and do a fork to support a consensus algorithm changes as an example. So that's what we did, and that was really good. Just on a related note, one of the challenges is with big data and AI, our challenge as a society is that our ability to make inferences is actually going up geometrically. We can actually figure out things that we were never able to figure out before. What's good is that we're getting combative technologies to solve this. There's a new concept in privacy called differential privacy. And the idea is, the problem is if you have these big data sets, figuring out who's in the data set is actually kind of trivial. Even if you take the name out, we can figure out who you are, no problem. And so differential privacy says that what we do is we basically inject noise into the data set to create improbability on the result, to reduce the ability for you to figure out exactly who it was. So that's on the good side. The problem is AI is good at both things. AI is good for minute pattern recognition. And so the problem is the crooks know that's what it's good at, so they're going to do minute pattern evasion, right? And so we've got to make sure that we've got to find a way to reconcile this wrestling match over who is going to be better at figuring out what the version of the truth is.